Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for tonight is December is this? December 4, 2024. And the time is, I will try to see my clock, 23:11. That will be minus 12, that will be 11:11 p.m. It's military time. Okay, my topic for tonight will be still a continuation of my long video format topic, DC circuit. And I am now presenting lesson number 23. It's a continuation of my long video format topic. Okay, let's proceed. Long video format topic. Okay. This is DC circuit lesson number 23. And the title of the topic for tonight will be Nodal's problem example. Meaning to say, we will be having a problem using the concept of Nodal's theorem. Okay, I will try to give you the problem. For the problem, I will be presenting this figure here. And this figure is actually similar to the figure of lesson number 19. Okay, they are similar. There must be a reason behind that why they are similar. Because I would like to solve lesson number 19 by using Nodal's theorem. So at the same time, I will be fact-checking the solution of lesson number 19. Because according to lesson number 19, I think lesson number 19 is superposition theorem, and that solution is actually being presented, and actually I now know the answer to lesson number 19. The current passing through the load RL is 1.219 amperes. That is by using superposition theorem. So by using the same figure, we'll try to solve for the current passing here. That will be designated by IL using superposition, using Nodal's concept. Okay, let's try to bring out the solution of this one. This will be an AC one now because the last time around, lesson number 22, I discussed how the concept of Nodal's theorem actually works. And actually there was a formula on how to bring out the solution. And that formula is actually represented by this one. Okay? Okay, I will try to read the equation. This was derived using the concept of lesson number 22, that is the Nodal's theorem concept. BL, the node voltage, the voltage across this node here, node or junction, is termed to as B sub L. And according to lesson number 22, that B sub L is actually being presented by this equation here. That is E1 over R1 summation plus E2 over R2 plus E3 over R3. The resulting denominator will be the summation of 1 over R1, 1 over R2, 1 over R3 plus 1 over R sub L. This is close bracket. For us to use this equation here to solve the given problem, which is the same as lesson number 19, we will be using the value of n here equal to 3. The letter n here is 3, and this 3 here represents the 3 voltage sources. First voltage source, second voltage source, and third voltage source. Okay? There are 3 voltage sources, that's why I use n here equal to 3. So I just stop at the subscript 3. Okay, since there are 3 voltage sources, the last part here will be subscript 3. Okay, the bottom portion for the resistance, the last part is subscript 3, of course, plus the load RL. So this is the formula and how to compute for B sub L if n is equal to 3, like what is given. So this is an easy matter now. Since the equation is a little bit, it's not complicated, but it involves fractions. So for us to be, what you call this, very neat in the presentation of the solution, instead of writing the values immediately here. Okay? I would like to compute for the total value of the numerator separately. So I represent the numerator to be the summation of E1 over R1, E2 over R2 plus E3 over R3. All the values here are given, so it is just a matter of substitution now. A1 is 24, R1 is 1, E2 is 18 volts, R2 is 2 ohms, E3 is 12 volts, R3 is actually 3 ohms, right? So we will be taking the summation of this one. Luckily, the ratios are actually exact values. So 24 over 1 is 24, 18 over 2 is 9, 12 over 3 is 4. The summation of this one, the summation of the numerator is actually 37. For the denominator, I just represent the denominator as the summation of the bottom portion. So it will be the summation of 1 over R1, 1 over R2, plus 1 over R3, plus 1 over R, close quantity. R1, R2, R3, and RL are all given, so it is just a matter of substitution now. So this will become 1 over 1, plus 1 over 2, plus 1 over 3, plus 1 over 16, close quantity. And if we try to take the individual summation of this one, 1 over 1 is 1, 1 over 2 is 0.5, 1/3 is 0.333, and 1 over 16, a small number, less than 0. Less than 1, 0.0625. If we take the summation of this one, the summation of the denominator will be 1.985. So in the computation of the node voltage V sub L, that will now just be an easy matter because the formula was derived. Okay? It's just a matter of computing now. So it will be the ratio, the numerator is 37 according to this. The denominator is 1.8955. So if we try to take the ratio, the value of V sub L, meaning the node voltage, is actually 19.52 volts. So this is 19.52 volts. The voltage across this. That is the so-called node voltage or junction voltage. Okay? Since we know the voltage across this, and it is the same as the voltage across the load RL, we will be using this equation here. It emanates from the equation voltage is equal to IR, so I now will be equal to voltage over R. So placing the proper subscript, it will be V sub L over R sub L. V sub L we have computed already, 19.52 over 16, and what comes out is 1.219 amperes. So this will be our answer. It is the same. It is the same as lesson number 19 by using the so-called superposition theorem. So actually, we fact check lesson number 19, the superposition theorem solution. Because lesson number 19, the answer is like what I said, is 1.219 amperes. I've got the record. You could go back to my lesson number 19. And as of now, by presenting the Nodal's theorem problem concept, what comes out is still 1.219 amperes. That's it, guys. So meaning to say, Nodal's theorem is actually a very neat solution, a simple one. It is concise because as long as you know the equation, okay, we could compute for V sub L, and after computing for V sub L, I will just take the ratio V sub L over R sub L, and that will be I sub L. Okay, that's it, guys. So for those of you who would like to subscribe or would like to watch my long video format topic on my channel is at youtube.com/@ProfDavidJ. And if you want to share it, please click share. You will learn something from it. Okay, good evening from Los Angeles. This is Professor David J. De La Suez.